Welcome to the Samueletini Show, where business, innovation, and sustainability converge to drive progress. Are you ready to uncover solutions shaping our future? Let's dive in.
Welcome to a new episode, and today we are going to discuss something that is at the forefront of the discussion every day. So AI and the role of the data centers. So how we can power in a sustainable way such a huge demand for data that AI requires. And we do it today with an innovator, a change maker, Yuval Bachar, who is the CEO and founder of ECL. Thank you so much, Yuval, for joining us today at the show.
Thank you for having me. I really appreciate it.
Yuval, you have a wonderful story and now you are on the path. You had a wonderful experience at the big names that everybody knows, so the blue chips and others. And we want to understand, what is your journey, how you have ended up, in this field of sustainability and AI.
So I started from engineering roles. So I was working as an engineer for many years. I started my career in DEC, Digital Equipment Corporation, and then moved to Cisco for many, many years, since 96 to 2010. I got excited into the data center world in 2009, and that's where I actually started getting deeper into the data center side. Until that, I was developing mostly optical gear, routers, switches, etc. In 2009, I joined the CTO office of Cisco, and I was actually in very early stage involved in building the hyperscaler data center. So I was the Cisco contact person for Amazon, Microsoft, Facebook, Google, and Apple, and I was working with them closely on their project and learning how they actually started their hyperscaler. At that stage, it was very early stage of Amazon and Facebook, Google, and Microsoft were not even playing in the cloud at that point. Very, very interesting and very, very fortunate to be part of that role. I understood very quickly that I need to be on the side of the hyperscalers to have an impact. And that's where I decided to move to Facebook, today Meta. And I moved to Facebook to actually build their hardware networking division of Facebook, and started doing open source technology and build switches and deliver platforms which were first deployed into the Facebook data centers, but then opened into an open source environment. And a lot of people after that took it as white boxes and redeveloped that. After 2 years at Facebook, I had an opportunity to actually expand my responsibility. Up until the days in Facebook, I was focused mostly on the networking side of the world. I had a very deep knowledge of the networking hardware, software, stacks, etc. But then LinkedIn came and offered me an option to actually own the whole data center, including the compute side and the infrastructure and everything, and be the lead of the technical side of the LinkedIn data centers. And that opportunity was amazing for me because I started working on data centers which are being built from scratch in different environments, with co-location, with large data sites, with private data center, non-private data centers. I was exposed heavily into the server world and developed a platform called the Open 19 platform, which was a widely accepted technology for sharing server form factors across suppliers. And we had multiple big names behind this. Today, this organization, which was a nonprofit initially, is actually the hardware division of the Linux Foundation. So it was actually entered into the Linux Foundation and became the hardware division of the Linux Foundation. And then Microsoft came and acquired LinkedIn. That was a major event for us. Initially, LinkedIn continued to operate independently, but there was a point where Microsoft required LinkedIn to move into Azure as a platform. And at that point, I made a decision to actually make a change and start getting more involved in AI. And it was really early stage AI. So I moved to Microsoft and developed early stage AI platform, which was doing self-healing for data centers, which means the data centers knew how to actually identify problems, correct them automatically, and create a zero hardware failure virtualized for customers. That was an incredible project. And it was pre-ChatGPT, so it was early stage AI. We were still figuring out how to actually deploy it into production, etc. In 2020, I decided that I need to do something else. And I need to actually deliver something that will have a much bigger impact, because being part of the large companies is great, but your chances of actually having a significant impact are relatively low, no matter how innovative your technology is and what you want to do. And made a conscious decision to actually leave the golden cage I had and move into a startup environment.
Yeah.
It was my first startup, so I did a lot of innovative projects in the large companies, but it was my first startup, and definitely first startup as a CEO. When I had to figure out things beyond the engineering, I had to figure out the business side, I had to figure out all the relationships, etc. So in 2021, so 2020, that was on my mind.
Mhm.
And in 2021, I decided to leave Microsoft and start ECL. And started
Fantastic.
ECL with a few goals, which are very, very important for us and still are tenants for what the company is. One is be able to
Fantastic.
build a fully sustainable data center and
Mhm.
prove that fully sustainable data center is possible. And the reason we put it as a primary goal is that for a very long time, a lot of the large companies, some of them I worked for, some of them I didn't, were actually claiming to be carbon neutral. But
Yeah.
carbon neutral never let's redesign the data center to be sustainable. It was always let's buy credits and actually offset what our data centers are doing, which is a way to actually say I'm carbon neutral. But in reality, the design of the data centers did not become more sustainable. It just was offsetted by large credits and ways which are more on the marketing side, less on the engineering side. And for a long time, people were claiming that it's not possible to build a fully sustainable data center. And that's, for me, it's like as being a disruptor and an out of the box thinker. It was basically saying, okay, if somebody says it's impossible, they need to go and do that. So that was the first thing. The second was, for a long time, I was exposed both to the hyperscalers and to colocation business, and I saw a huge gap between how hyperscaler data centers have been built and how colocations are operating. And
Maybe
that
you
gap,
can, Joel, for the not engineering part of the people
yeah,
that are listening, can you explain a bit the terminology of the data center so that even
yeah.
the not tech from
So
us, they will understand?
yeah, sounds good. So what is a data center? Data center is basically a location where you power and cooling capacity and a building. And what you as a customer usually comes and bring your equipment. Your equipment can be standard servers, can be GPUs, can be networking gear, can be storage elements, etc. They're all sitting in one big facility usually, and usually it's divided into hallways. In every hallway, you will see a certain clusters of GPUs, CPUs, and servers, and they deliver a service. Uh, I'll give you two examples. The cloud services, for example, give public cloud access. So they have a large, very large facilities with millions of servers, which are delivering cloud services to all the enterprises which are running with cloud services. And on the other side, you can see solutions like the solution from LinkedIn, for example, which are just serving themselves, so doing their own private cloud. And Facebook was the same thing, creating a cloud services, but it's an internal cloud, it's not a public cloud. Now, these are all elements which create very large demand from the number of servers that you have, the power
Mm,
that you need, and as a result, you are having impact on the sustainability goals
mm,
of the company because you're
mm,
consuming a lot of energy and you're generating impact to the environment. If it's any kind of impact on the energy, if it's impact on the CO2, embedded CO2 and delivered CO2, and everything else that you have in the process. So that's how data center work, and that's what
fantastic.
our data center are.
Mm,
Now, what happened in 2023 was a leap, a major leap in this environment. ChatGPT came into life and basically said, hey, we can do AI to everybody. And instead of doing search in Google, now you go to ChatGPT or to Grok or anybody else and do the searches over there. What's standing behind those is huge models, which actually has been trained for a long time with some cases hundreds of millions, some cases trillions of items and tokens that were given into them. And then those are now actually responding to our questions. So if you have to ask a question into ChatGPT, for example, it goes to the model and basically apply the question to the model. The model gives a response based on the learning that happened, the learning called LLMs. That's large language models.
yes.
These are very large and very power hungry elements that we
Yeah.
have. With that, another thing happened is that we built a grid which was very robust for a very long time. And in the early 2020s, we started to get fluctuation on the grids themselves. They started to be unstable because of unreliable energy that we inserted them and demand, which was growing very, very fast. And as a result, what happens is that we started to run out of power for those data centers. And when ChatGPT came in and the AI deployment started to happen, we basically got to the point that we ran completely out of power because the demand for power became so high that the utility said, I don't have any more power for you to give you, and you have to find a solution. And that's an area where ECL is actually
coming
shining.
in.
Yeah, when we came in and said sustainable, we said sustainable cannot be on the grid because the grid has a carbon footprint into it because the generation of energy into the grid is coming from different facilities. Most of them actually have a CO2 emission coming out of them. If it's natural gas, coal, or any other solutions, some of them are sustainable, coming from solar and wind, etc. But most of them are actually not sustainable and has a carbon footprint in it. So at ECL, we said, you know what? To make it 100% zero emission, let's take it off the grid and operate in an island independently and generate our own energy. And what's the best way to generate energy which is clean is hydrogen based. When we use hydrogen based generation of energy, we have a zero emission because the process that we use is a fuel cell process, and we inject on one side hydrogen, on the other side oxygen, and the byproduct of the generation of energy from those fuel cells is water. So we take the water. So not only that we don't have any emission coming from the side, we also produce water in the process. So we also not taking water from the environment around us, and in some cases can even give back water into the community that we are operating in. And that makes us on-site, zero emission and zero water, which is the ultimate option for sustainability. You don't have a carbon footprint on operations. You do not use water. Your noise level is very low. Then you don't impact the environment around you.
Fantastic.
Now, the second thing that we did is we wanted to build a high-performance data center. And high-performance data centers is a changing platform. And we basically said, okay, what is high performance for us? High performance is in two levels. One is the capability that we can put, what kind of load, IT load we can put in their server, GPUs, etc., and how dense it is. And the second thing, which is also very important for sustainability, is how efficient we operate it. And I'll explain to you how operations efficiency happens in data centers. So data centers has a metrics to actually see how much overhead do you have in your system. So if you run 1 megawatt of data center, how much power do you need to actually run it? And run it means cool it and deliver the power to it, and lighting and fire suppression, security and everything. The average in the United States today is 60% overhead. What that means is that for every 1 megawatt that we have, we need 1.6 megawatt to operate it. And the global is actually higher than that. It's about 75% overhead. We put a target to be sub 10% overhead, which is a huge jump. It's 6 to 8x. And we did this with a lot of technologies and a lot of software and hardware development. We're able to achieve a 5% overhead over here in Mountain View in our headquarters, which means we operate on a 5% compared to a 60% overhead. Makes it much more efficient and much better use of the power. Okay, so that's the first thing, is the efficiency.
Fantastic.
The second thing is the density. What's happening today in the world of AI, we got to the point that the servers are very high power in a very small footprint. I think the biggest system we see today is 150 kilowatts on a 4-foot rack, which is incredible density. Just to give you a feel, 150,000 watts is the equivalent to 150 homes in the United States. And that is sitting on a 2 feet by 4 feet. That is the size of that. It's equivalent of a neighborhood, a whole neighborhood consumption. Now, we try to put a lot of these together. So we try to put tens of them and hundreds of them together. That means that the density of the power becomes very, very high. For ECL, we decided we'll be able to support always the bleeding edge of the density that needed. So today we support 150 kilowatts per rack, and we will move forward to 250, 300, 500, 600 that NVIDIA is now asking us to deliver in the next few years. That's another aspect of it. And the last aspect of what we're developing is actually high performance management system. We have a highly sophisticated management system that knows how to do self-management of the site. So the site is doing micro adjustment and constantly change its operating point to be optimal to what the customer wants us to operate at. If it's low cost, if it's low energy cost, high availability of sustainability, low use of water, whatever the customer asks us to do, that's what we actually operate under. So that
Fantastic.
software is sophisticated. We developed it from scratch because there was nothing else out there. So in general, what we do is we give a package to our customer saying, here's a package of the data center. It's very high end, very high performance. You bring your equipment and we'll run it for you. So
Fantastic.
enabling a lot of companies that do not have the knowledge on how to actually build the data center to be participating in the AI wave that we see right now. And by delivering to them the product that enables them to actually operate properly, independently.
Fantastic. And I want to know, can you give us some example of projects that you have developed? And then I want to ask, so your data centers, the one you have now built, they are completely off grid. So hydrogen power, then you use the
Yes.
water, if I understood correctly, also either for cooling purposes or other, or you put it back into the environment. And can I ask you, which type of hydrogen do you use? So, you generate or you buy it from outside, you generate yourself?
Yeah, so we have multiple options. In general, for the large sites, we buy from the outside. So there are producers of hydrogen which sell us from the house outside. In the supplier that comes from the outside, there's a blend of types of hydrogen. The most dirty one is called gray hydrogen, and that's made out of natural gas, and it has a carbon footprint embedded to it. We try to avoid that as much as possible. The second tier under it is called a blue hydrogen. Blue hydrogen is a hydrogen which was generated from natural gas, but went through what's called carbon capture. So it does not have a very high carbon, actually has a very low carbon footprint on it. So we focus mostly on that, and we try to insert green hydrogen as much as possible. Green hydrogen is a hydrogen which was generated from renewable energy. And the challenge with green hydrogen is the volume. There isn't enough out there for what we need to run the data center. So we blend blue and green and gray to make sure that it's actually available for us at the volume that we need.
Fantastic.
When we do any kind of that blend, we are better from a carbon footprint than any data center or any grid in the United States. And across the world, it's actually even worse in some cases. So it's going to take time for us to be 100% green because the supply of green hydrogen is not out there the volumes that we need. But the blue hydrogen is already have a significant impact, dropping about 80% of the carbon footprint for the grid compared to the grid if you were connected to the grid. So that's the hydrogen. We have another option, and that's generating hydrogen on site. If there is no hydrogen, for example, in a country or in a community we come in, we can use alternate methods. We can use methanol and run a reformer and generate hydrogen. We can use other methods to actually generate hydrogen to deliver to the site. In the long run, which is probably 5, 7, 10 years out, we are hoping that people will be able to pull out what's called white hydrogen, and that's hydrogen which is naturally occurring. And we can be pulling it out of the ground, and that's going to be the most optimal sustainable hydrogen. That's hydrogen which is naturally occurring, so there's no process to actually generate it. And as a result, it comes out with zero carbon on it, and in some cases even negative carbon on it. And then you just use it as is. That's longer term. That's 7 to 10 years out before we can actually productize that. So for now, just to summarize, we do blue and green hydrogen. We call it turquoise because when you blend green and blue, you get a turquoise color. And then in the future, we're going to get into more and more green, and potentially in the longer future, get into what's called the white hydrogen.
Fantastic. And thank you for this explanation. And we really hope that white hydrogen is still not there, but that will be a transformation, unlocking real big transformation. And then I go back to the question. Can you share some practical example or projects that you are deploying?
Yeah. So we are deploying one large project right now in Texas. It's a gigawatt of data center. Just to give you a feel, a gigawatt of a data center is the equivalent of 1,000 homes. So 1,000 homes, that's a very large community. That's a 250 to 350,000 people a power consumption. We do it in one location and we deliver that based on hydrogen that been delivered to us through a pipeline. That's a project that we started already, and we will deliver the first phase of it next year. And that project is going to be the initial breakthrough of building large scale data centers based on hydrogen. We do have a smaller site over here in Mountain View in our headquarters, which is demonstrating all of our technologies. And it's a production site. We have customers which are actually in the site, but it's a smaller site. But because we build modular, it's very similar for us to grow because the block that we have over here, it just repeated 1,000 times in Texas. It's not that we're building a 1,000x bigger block. It's 1,000 blocks of 1 megawatt each. And that gives us a tremendous advantage in how quickly can we build it and what's the cost for us to build, etc. So that's a very large project and a very smaller project. We as an engineering group have building blocks that we're building into it. For example, we developed the hydrogen generation plant. So the box which actually takes the hydrogen, makes it out of it energy, that's our box. And that we designed because we couldn't find something which was available for this technology. Some of the cooling system that we developed is actually our development. Definitely our software is a big project for us, which is running independently to enable this. And all of this together enable the delivery and actually democratization of data centers, because we want to be the place that not only 4 companies can build data centers in the world. We want everybody to be able to compete in this market, because the higher competition we have, the better we are as individuals which consume the services of those data centers.
Fantastic. And I can see also a lot of potential, for example, in emerging markets or other markets which they
100%.
don't have. For example, I'm thinking about Kenya, since we have huge geothermal untapped potential, that we are fantastic for production of green hydrogen. And I want to ask this, as a lay person in the industry, what is the uptake of your approach, let's say hydrogen, let's say the sustainable data center versus the traditional one, the grid connected?
Yeah, so you're talking about the adoption level, right? So who is accepting it?
Yeah,
So
yes.
we're working with a lot of customers. We're working with larger customers and smaller customers. I think a lot of people in the data center industry is a very conservative industry. So a lot of people say, oh yeah, show me this is actually working. So we have a few customers which are believing in what we're doing, and they are pushing forward with those projects that we're doing in Texas. But I think the big thing is going to be adoption of hydrogen-based generation of power and delivery into data center once we prove it on the first site. So once we build the first site at high volume and be able to prove it's actually working at scale, that's going to be the big step. If you compare it to traditional data centers, the challenge with traditional data centers right now, first, they don't have power. So if you don't have power, there's no data center. And the second thing, it takes time to build those data centers. Data centers are built on a 3 to 4 year cycle, and we're building, because of the modularity, on a 9-month cycle. So we are 3 to 4 times faster. So we can actually build many, many, many megawatts of data center while other people are building one site, and they have a dependency on the grid. So if the grid does not scale properly, then there is a problem. Just to give you a feel about the level of scale that needs to happen, we need to be able to actually deliver data centers at about 40 to 50 gigawatts in the next 4 to 5 years. Again, very, very large numbers. This is more than some countries' overall power consumption for those countries. And that's what's expected to be delivered as data centers. It's pretty clear today globally that the utilities will not be able to deliver that amount of energy. It's just not possible in the short period of time that we're talking about for utilities to be able to deliver on grid that amount. So there'll have to be a bridging capability for the next 10 years of non-grid connection, because the grid will just not going to be able to actually do that. So
yeah, no, fantastic. And it's also, I mean, what I like also your approach, I mean, from the news we read that now big companies, they are entering into agreement, deploying maybe mini nuclear and others, but I can see hydrogen as an advantage, being let's say, more sustainable than traditional nuclear power, which has also
Yeah.
come with issues.
And and nuclear power is 7 to 10 years out at least, and it's a problematic energy generation if you try to put it close to the data center, because data centers usually are close to urban areas, right? So in our site in Texas, there are people living about 150 to 100 meters away from us. Imagine you tell them we put a nuclear site 10
You
meters
don't
away from
want
your home, they will never accept that, right? But when we generate
Absolutely.
with hydrogen, with zero emission, etc., that's completely acceptable to them. So nuclear has its place. Nuclear will be connected to the grid, will feed the grid, but it's not going to sit next to the cities. It's going to sit outside and of the main areas where the risk is lower in case something happens. There wasn't a big event in nuclear for a very long time. When there is an event, it's actually a very bad event. So
Yeah.
a lot of people in the communities will not like to have a nuclear plant next to their homes or next to their communities. So I think nuclear is a great solution for energy, but
But
it's not solving the problem, not in the
mm,
short run, and not in the localization where it needs to be next to the data
mm.
center.
No, I also think also, with the pressure of the grid, which is, I think, 70 to 80 years old, putting, I
Mhm.
mean, what you say, 40 to 50 gigawatts in few years will be collapsed. So going off grid, it might be a more reasonable solution.
Yeah. And when you look at grid, right, grid has two aspects to it. One is the generation aspect, and that can you actually generate enough energy? But not just as a big of a problem because the grid is older, is that there's a transmission. Can you actually deliver the electrons from the moment you generate them in a power station to the endpoint? And transmission is just as big of a problem as the generation. It's not just the generation, it's how do you deliver the electrons? Hydrogen is changing this. Instead of moving electrons, you're moving the molecules, and then when you get the molecules at the endpoint, you convert it there to electrons. Then it's actually transporting energy through a media which is not electrons, and that gives it a huge advantage because it's easy. In some cases, it's easier to deliver that media. You can get it almost anywhere you want, compared to traditional grids that can take many years to get it to anywhere you want. And the second thing is based on pricing that we have today for hydrogen and hydrogen generation, we can actually beat the price of the grid. It's actually much lower cost than the grid will actually generate energy. If you look at our CNBC item that was talking about ECL, that CNBC item was talking about what we're doing and how we're doing it. And we're talking about 6 to 8 cents per kilowatt hour. That's very competitive in a lot of places.
And plus, with the hydrogen prices going down through the more adoption, that also will further reduce your pricing.
100%.
Mm.
Yeah.
So no, that is very interesting. And now to see, we have discussed with other guests the hydrogen revolution in the world that can enable, especially to the dirty job, that the decarbonized industry and data center, they are often overlooked. We discuss about, hydrogen car, EV car and others, but that is where I think hydrogen can give a wonderful
When
solution.
we finish the 1 gigawatt site in Texas, it's going to be the equivalent of tens of thousands of cars, hydrogen cars. There are not going to be tens of thousands of hydrogen cars.
Yeah.
So one site, one location, it has a much higher level of impact on the environment than trying to put it in automotive. I think automotive in hydrogen is probably more targeted for the trucks and high long haul cars, etc., which drive very long distances. The individual cars and the private cars for hydrogen, in my view, will take a long time. And it's not that technology is not there. It's just a refueling option. There aren't any gas stations, like hydrogen stations to refuel. And without gas station and hydrogen stations, there's no way for convincing people that they need to actually buy a car like that, because how do I actually drive long distances if there's no gas station? And I think that's the bottleneck for putting the hydrogen into the automotive. I know a lot of governments are trying to fix this, but it's a complex problem to solve. It's not a simple problem to solve.
And going back to the data center, because I think what you share with us is a massive amount of energy, 40 to 50 gigawatts, which is closely some countries here in the
Yeah.
global south, and they generate. So I want to ask, how do you see the trends? Would it be sustainable, or are we going towards a grid collapse?
Yeah, I think what's happening right now, what we're seeing is if you backtrack about 3 years, there's a huge effort to actually put more and more sustainable energy into the grid in the shape of solar and wind with batteries, without batteries, etc. Because of the huge stress to actually bring fast additional power, it took like a little bit of a backseat. And right now, what they're looking for is what are all the ways we have to actually enable energy into the grid. And so they're restarting old factories of energy and power stations, which some of them even used to run on coal, right? That will be shut down. They bring them back online because they need the power right now. They're building a lot of natural gas based generation because it's faster and you can actually build it in a relatively quick way than compared to building very large facilities of nuclear or anything else that connect to the grid. So all of these are going against all of our efforts to actually go to a more decarbonized grid, but that's because of the urgency of delivering power very quickly. I think it's a cycle. It will go back into renewable energy probably in a few years, where the focus will go back to renewable. Right now, there's an urgent delivery need. So people will try to deliver in any way they can, and including deprioritizing the sustainability side of the energy generation. And it's sad. It's not the direction we want to go, but it might be a necessity right now on the short term for the next 4 to 5 years, and then switch back. We took a leap and said, okay, we're gonna do sustainable energy day one. We don't care. It's a part of our value proposition, and we'll continue to do it for as long as we can to deliver hydrogen based generation, which is zero emission. Can everybody do that? No, it's complex. It's complex to do that, and it's going to take some time for people to do more adoption. But I think after we've finished the first large sites and demonstrate that we can do it at scale, there will be more and more attempts to actually build data centers which are going to be hydrogen based. Because a lot of people are saying, okay, let's see if this is actually working, and we guarantee to our customers that will work. It's not a question of if it's going to work. The question is when we're going to make it work, and when for us is 2025.
Fantastic. So by the end of the year, maximum next year, you will be online with the thing, and
with multiple hundreds of megawatts. Yeah,
fantastic. And that one will help a lot, I hope, change the wind from using coal and terrible fossil fuels towards putting towards hydrogen. That will also
100%.
help. That will also help a lot, to power EI more sustainably. And, I learned so much in this episode, and it was a wonderful conversation. The last thing, where do you want to take ECL? Just for a last question, where do you want to go with your company after maybe you have done your first big project?
Yeah, so the goal for us is to perforate our technology across the board, and it's building our own data centers, building 4 or 5 or 6 or 7 of those very large data centers, building smaller data centers, which are going to be more for and not necessarily the AI factory as defined by NVIDIA, but more for closer to the cities, smaller sites. They will not necessarily do the LLM function, but will do other functions that needed with GPUs, 10, 15, 20 meg of data centers, and actually working with other data center companies and enable them to leverage our technology. So enable them to be able to actually build their own data centers. We know that we cannot build all the demand in the data centers out there as a company. We want to enable other people to do that. So we're looking for the right partners to say, here's my technology, go build your data center. And that's something that we're looking for to do in the next few years, build a significant footprint and be a very significant player in data centers, number 2, number 3 in the United States if we can, and globally spread out in 2026, 2027 with partnerships and with direct data centers that ECL are going to be building down the line.
Fantastic. And I'm looking forward for this revolution, which will really be, a concrete step, which many people, they don't know on how to power AI and data center, the hunger for data that is out there in a more sustainable way. Yuval, has been a pleasure and honor having you on the show, and I'm sure we can book you for maybe in 2026 to see where you have gone. Thank you so much, Yuval. It's
Thank
been a
you very
pleasure.
much for having me, and I'll be more than happy to actually participate in future events.
Fantastic.
Are you satisfied after this wonderful episode? Let's continue together our sustainability journey.